Okay, Chapter 3, Lesson 5, Transformation of Linear Functions. On the next slide, we're going to actually put on the brown part or on the back cover of your notebook because we are going to do transformations in about 3 different lessons. And so if we just take them on our brown part of our notebook, then we won't have to retake them when we get to them in the future. So go ahead and pause it here and take all these and then listen to the notes after you're done taking them. The first thing we're going to look for in linear equations, and remember, we're talking about our y equals x equations. Any negative sign out front is going to flip the function. So if I take this equation here and I put a negative in front of my x, instead of a line being a positive slope like this, now with the negative sign out front, it'll flip the function going down from left to right. Number 2, any number inside the grouping symbols with x will move the function right and left. Now, it's opposite of what we're going to think. If it's inside the grouping symbols with x and it's a minus, that's when it's going to move the function to the right. And if it's a number inside with x being added, then it will actually move our function to the left. Any number added to the end of the equation moves the function up or down. So if I had a plus number at the very end of my equation, it would go up, and minus a number at the very end of my equation, it would go down. Any number multiplied out front is called a dilation. It causes a horizontal stretch if it's a number between 0 and 1, so like your fractions, or a vertical stretch if it's a number 1 and up. Basically what the dilation is, it's the slope of the function. So if we're starting originally with y equals 1x, that's like up 1 over 1. But if I change it into y equals 1/3 x, now instead of going up 1 over 1, up 1 over 1, I'm going up 1 over 3, up 1 over 3. So it's actually doing a horizontal stretch. If I change it into y equals 4x, like 4 over 1, now I'm going up 4 over 1, up 4 over 1. So that one is a vertical stretch. It's going to make our line more vertical. So again, our original equation is going to be f of x equals x, or remember from our function notes, that's the same thing as y equals x. And we're going to use our rules from the last slide in order to describe each transformation. So if I take the original y equals plain old x and I put a plus 4 on the end of the equation, that follows rule number 3. And so this equation would be moved up 4. Number 2 at the end of the equation is a minus 1, down 1. Number 5 follows the rule about the end, up 6. And that's it for this first section on any numbers added or subtracted to the end of the equation. Rule number 2 talks about numbers that are inside the grouping symbols, and remember that those are opposites. So this function would go left 8. This one would go right 13. And those are the only ones that have numbers added or subtracted inside the grouping symbols. Then we have these next ones, which are following rule number 4 about numbers multiplied out front. So 0.2 is multiplied in front of the x. 0.2 is a number between 0 and 1. So this would be a horizontal stretch. 1/3 is a number in between 0 and 1, horizontal stretch. 3 is a number greater than 1, vertical stretch. And 5/2 as a decimal is 2.5, which is greater than 1, vertical stretch. Okay, this mixes all of the rules together and has multiple rules per equation. So this one I have a negative sign out front, which is a flip. And then I also have this 1/4 multiplied, which is a horizontal stretch. Number 11 has a negative sign out front, which is a flip. And then a 12 multiplied out front, which is a vertical stretch. Number 12 has a +3 in parentheses, which is left 3, and a +5 at the end, which is up 5. Number 13 has a number between 0 and 1 out front, which is a horizontal stretch, and a number added inside, which is left 6. Number 14 has a vertical stretch because of the 2 multiplied out front, and also down 7. Number 15 has a flip because of the negative sign out front, and also down 9. Write a function represented by each graph. So on these, a couple things we're going to check for is slope, because that would be our number multiplied out front. We're going to check to see if it's flipped, because that would be a negative sign out front. And we're going to check for any right or left or up or down. So number 16 starts with a flip, because instead of going up from left to right, it's going down. I look at the slope and it's 1/1, so there's not going to be a number multiplied out front. And then here is my origin, and I can see that from the origin it's moved up 2, +2. Number 17 is not a flip. There's going up from left to right, so it's just going to start with x. And I check my slope, which is up 1/1, so it's just going to be 1x still. 1, 2, 3, 4. And I'm starting at -4. Number 18 starts with a flip, so negative. My slope is still 1/1, and this one is starting at down 1. The function f of x gives the cost in dollars for x music downloads that cost $2 each. Write a function g of x to represent the cost in dollars for music downloads that cost $1 each. So g of x equals $1 each x. Describe the graph of g of x compared to f of x. Well, because of the 2 multiplied outside, the f of x is a vertical stretch. Kyle is buying strands of outdoor lights for his luau. The total cost of the strands can be modeled by the function 8.97s. He received an email with a coupon code to receive $5 off his online purchase. So the final cost of his purchase can be modeled by g of s equals 8.97s minus 5. Describe the translation. So here's the original, and the new one is exactly the same except for -5 at the end. So the translation would be down 5.